All right, everyone. This week we are going to talk about the periodic table of elements. All the atoms that we've been talking about in class can be found on the periodic table of elements. We have worked with hydrogen. We have worked with oxygen. We have worked with carbon. So all of these things that we've been working with, you can find on the periodic table of elements. And you can learn so many things about these elements, these atoms, from the periodic table. So let's get started. First of all, it's important to learn about the periodic law, or something that's periodic. So something that's periodic occurs at regular or generally predictable intervals. I'm sure you can think of something that happens periodically, such as maybe your classes at school. They happen at regular intervals, about an hour, things like that. Maybe you're watching a football game. The quarters happen at regular intervals. There's lots of things in your life that happen regularly. So, periodic means something that happens regularly or at regular intervals. Periodic law states that physical and chemical properties of elements are related specifically to their atomic number, and those atomic numbers happen at regular intervals. So we've discussed in class that atomic numbers represent the number of protons in the nucleus of an atom, and the protons determine what kind of atom it is. It happens at regular intervals, right? They go up by one proton every time, so we get new elements, new atoms, every time we add a proton or take away a proton. Either way, when the protons change, so does the identity of that element, and it happens at regular intervals. The periodic table of elements it's the arrangement, it's a setup of those elements, the atoms we've been dealing with. We call them elements. It's an arrangement of those based on patterns, based on things that happen at regular intervals, based on periodic law. All right, pretty simple. Now let's take some notes. First, it's important to know what an element is. You've probably heard us refer to elements in class when we're talking about atoms, because they're really very relatable terms, right? You can find all the elements on the periodic table. All matter is made of elements or a combination of elements. That probably sounds like atoms, right? All matter is made of atoms or a combination of atoms. Well, those atoms we identify, individual atoms, we identify them as elements. Okay, an element is something that is only one kind of atom. You can't separate it into anything else. So it is one kind of atom. So we can kind of refer to elements and atoms as basically the same thing, because one kind of atom equals an element. All right. On the periodic table of elements, you will find many, many elements, over 100 elements that we know, and periodically, every now and then, we discover or create in a science lab new elements. Pretty easy. So elements and atoms, very similar. Elements are one kind of atom. So we refer to all the things on the periodic table, hydrogen, carbon, oxygen, we refer to them as elements because they are one kind of atom. All right, there are three classes or kinds or general groups of elements. Three general groups or classes of elements, right? You have your metals right here. You have your nonmetals right here. And then you can see this very important zigzag line separates the metals from the nonmetals, right? And along that zigzag line are something we call metalloids. And we will talk a little bit about each of these. So you got your metals, obviously. Most of the periodic table is made of metals. You have your nonmetals and your metalloids. On most periodic tables, they are shown in different colors. So let's talk about metals. Metals. They are located clearly on the left side of the periodic table. Clearly on the left side of the periodic table, as you can see here, they are in green, right? We say that they are to the left of the zigzag line. This is the zigzag line that separates metals and nonmetals, right? With one exception, of course, hydrogen way over here, but definitely not a metal, right? Hydrogen's a gas. All right, we know a lot about metals. You encounter metals in your everyday life, so you know some of their physical properties, things that you can see or touch or smell, right? Metals are ductile, right? Ductile means that you can, maneuver them, you can bend them. They're good conductors of electricity. Most of your wiring, most electronic wiring is made of copper, which is clearly a metal. They're made of copper wiring, okay? They're good conductors of electricity. Metals are malleable, which means you can pound them into sheets. You have seen aluminum foil. Okay, aluminum foil is aluminum that has been pounded into a sheet. Metals are shiny, and almost all metals are solid at room temperature. There is one exception to that rule, and that is mercury. Mercury is liquid at room temperature, and mercury is also very poisonous, so please don't try and find some to play with at room temperature. Chemical properties of metals. Metals are generally, they like to react with other things, especially the metals on the very left side of the periodic table. They love to react quickly. Some of these metals are very volatile and react violently. We will talk about that. I have an interesting video you're going to enjoy seeing. Metals. There we go. Moving on. Non-metals. Non-metals. Obviously, that's right, they're not metals. Seems really simple, right? Non-metals. Okay, those are on the right side of the periodic table. You can see them here. Non-metals are on the right side of the periodic table. Many of these don't like to react very much. Many of these non-metals don't like to react very much. That is their chemical property. Chemical properties tell us how elements react with other elements. These elements generally have full or almost full outer levels of electrons. And we will talk about why that is so important to how they react with other elements very soon. Right? These ones all the way to the right, this last set of elements right here on the periodic table has a special name called the noble gases. The noble gases do not like to react with anything. They do not like to react with anything, so they do not react very often. They are called the noble gases. Non-metal physical properties is pretty easy to remember as long as you know the properties of metals, because non-metals are the exact opposite. The opposite of metals, right? They're not ductile. You can't maneuver them very well. They tend to crush instead of, being able to bend. They're not malleable. You can't pound them into sheets. There will be no foil of sulfur. This is sulfur. It's a nonmetal right here. There will be no foil of that. If you try to pound it, it's going to turn into just basically dust. They are poor conductors. They are absolutely not shiny. You can see that sulfur right there is not shiny at all. Some are gases at room temperature. Those noble gases, all of these are gases. You have oxygen, that's a gas. These are non-metals. So most of them are gases at room temperature. They are the opposite of metals as far as their properties are concerned. And once again, all the way to the right of the periodic table, to the right of that zigzag line that we talked about before. To the right of that zigzag line we talked about before. Non-metals. All right. And the metalloids. Kind of a weird name. Sounds interesting. Maybe sounds like it's from a different planet. But it's not, folks. Metalloids all happen here. All right, metalloids are very few, very few. They are just these purple ones you see here on the periodic table. And you can see that they tend to follow that zigzag line that separates your metals from your nonmetals. The metalloids follow that zigzag line. They're on the border. And once again, they're almost always a different color to let you know what they are. They will bond with other things. They will react, but they're in no hurry to react with other atoms, some of them more than others. The physical properties of metalloids are some properties of metals and some properties of nonmetals. It's really kind of specific to the metalloid itself, so you would have to find out more about that specific metalloid to determine its properties. There's not really a lot that is similar about these. So they're very different parts of the periodic table. The metalloids are very different on the periodic table than other things. All right, now we're going to talk about how to read the periodic table. What can you learn about the periodic table? How is the periodic table arranged? Well, the periodic table is arranged in groups, also known as families. Groups or families, and these are, that's right, columns. The groups or families are columns of the periodic table. You can see they go up and down, folks, up and down. Right? There they are highlighted. You see them. You see them. They are being highlighted up and down on the periodic table. Right. You can see that there are 18 groups or families, starting with 1 and moving all the way over to 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. 18 groups or families on the periodic table, and they are the columns, folks. The columns on the periodic table. And they are arranged that way for very specific reasons, and I'm going to tell you what those are. All right, once again, groups or families. There are 18 groups or families on the periodic table. They are numbered from the left side to the right side. As you move down that column, the atomic numbers and the atomic masses increase. As you move from the top of the periodic table to the bottom, the elements get heavier and they have more protons. Right? Elements in the same group or family have the same number of electrons in that very last outer shell, which once again will be very important soon, and we will talk about that. But it's important for you to know that atoms of elements in the same group or family, that column, they have the same number of electrons in their outer shell. And those outer shell electrons, those are responsible for chemical properties. Those are responsible for how they react with other elements, other atoms, and that is important. Groups have similar physical and chemical properties. So if an element is in the same group as another element, you can pretty much know what it's going to look like and how it's going to react. It's really cool. That's why they arrange it that way, because they are similar. That's why we have the periodic table set up the way it is, because these elements are similar to each other in that way. They have similar physical and chemical properties. Now let's talk about those outer electron shells, those outer electrons. They're very important. They have a special name called valence electrons. Interesting name? Yes. The valence shell, or the valence orbital, is the outermost shell. Okay, it's the one on the outside. You can see this one's on the outside, that one's on the outside, that one's on the outside. Right? It's not the inside one. It's not any of the ones on the inside. This is the outside one. It's not any of the ones on the inside. It is the outer shell, right? Remember, first electron shell can hold 2, and the other ones can hold up to 8. All right? Electrons in this valence shell are used for making chemical bonds. It's how atoms and elements bond with each other to make, you're right, molecules, right? And an atom, it wants its valence shell to be full. The atom wants to be full, so it wants that outermost shell to be full. So atoms with very few electrons in their outer shell want to bond with somebody else very much to fill those up, and atoms or elements with almost a full shell, they want to bond because they're so close to being full. So valence electrons, very extremely important. It's the outermost shell. It is what electrons make those chemical bonds. Okay, it's how atoms make chemical bonds. They use these electrons, right? And they want that outer shell to be full. Very important. They want that outer shell to be full. There we go. Examples of elements with the same number of valence electrons. Here we go. One in their outer shell. You can see all of these have exactly one